Welcome back to the deep dive. You know, you see them everywhere now, don't you? AI agents.
Oh, absolutely.
They're in customer service, they're doing data analysis. It feels like they just popped up overnight. The buzz is just incredible.
It really is.
But, you know, for developers, the question isn't just, wow, AI, it's how do we actually build this stuff? And maybe more importantly, how do we make it play nice with all the software we already have? That seems like the real puzzle.
It is. It's a huge question, especially for bigger companies, enterprises. They've got these massive, complex systems already.
Right.
And the pace of AI is just, it's lightning fast.
Yeah.
So trying to plug these super smart new models into that existing structure,
Yeah.
it needs a smart approach.
Exactly. And that brings us perfectly to our topic today. We're doing a deep dive into something from Microsoft called Semantic Kernel.
Hmm.
Now, think of it as like a crucial bit of middleware. It's an open source toolkit basically for C#, Python, Java,
Right.
and it's designed to make building these AI agents and plugging them into your apps not just, possible, but actually pretty efficient.
Efficient is the key word there, I think.
So our mission today is to really unpack Semantic Kernel. What is it? Why is everyone talking about it now? Why the buzz? And how does it kind of give you a shortcut to understanding where AI development is heading?
So good.
We'll dig into the core ideas, the bits that make it enterprise ready, and look at an example based on the Microsoft Learn docs you shared.
Great. So yeah, let's start with the core idea. What is semantic kernel?
Fundamentally, it's a lightweight SDK, open source.
Okay.
And its main job, it's to help developers like you build AI agents and, crucially, integrate AI models, the cutting-edge ones, right into the code you already have. C#, Python, Java, it really tries to smooth out that whole process.
So it's more than just like sending a query to an AI model and getting text back.
Oh, much more.
It's really about weaving that AI capability into your existing tech stack, making it feel like it belongs there. Precisely.
Yeah.
That's the whole efficient middleware concept.
Yeah.
It's not just talking to the AI, it's the bridge.
Uh-huh.
It connects the AI's brain power, if you like, to your existing code, your databases, your APIs, your infrastructure. So they work together smoothly.
Right.
Think about a business wanting to add AI features. They probably don't want to rip everything out and start again.
No way.
This lets them leverage what they've already built. It's a big deal, actually.
I can see that. Okay, and the name itself, kernel. That sounds pretty central. What's the kernel doing in all this?
Yeah, the kernel is the core. It's like the brain or maybe the central nervous system of the AI application.
Okay.
If you're a developer, the analogy of a dependency injection container might click.
Oh, okay. Yeah.
It basically manages all the different pieces, the AI services, the plugins with your code, the memory, everything your agent needs. It's the single place you configure things, coordinate actions, and this is really important, monitor what the agent is doing.
Monitor how?
Well, when you ask the AI app to do something, the kernel figures out, okay, which AI model should I use?
Right.
How do I build the right prompt? It sends the request, gets the response, parses it,
Right.
and gives it back. But along the way, you can add your own logic. Middleware, events, for logging, for checking things, maybe for those important responsible AI step.
Yeah.
It's pretty robust.
That makes a lot of sense, like an air traffic controller for the AI's tasks.
Something like that, yeah.
So that sounds solid technically, but why the big buzz right now? What's making enterprises sit up and take notice?
I think a huge part of it is the focus on being enterprise grade. That's not just marketing speak here. Microsoft is using this internally. Other big Fortune 500 companies are adopting it. And the reason is it's built to be flexible, modular, and really importantly, observable. You can see what it's doing.
Observable, that ties into the monitoring you mentioned.
Exactly. It gives large organizations the confidence and the control they absolutely need to deploy AI seriously across the board.
And I remember reading in the sources about specific features for that, like telemetry support, hooks, filters, things that help with security and responsible AI.
Yes, absolutely critical.
That seems huge, right? Because just trusting a black box AI in a big company, especially with sensitive stuff, that's a non-starter.
You've absolutely nailed it. Those features aren't optional extras for serious deployment. They're essential, especially if you're in finance or healthcare or anywhere with regulations.
Right.
Semantic kernel helps turn the AI from this kind of mysterious black box into something you can audit, something that's accountable, part of your standard business logic. Think about needing an audit trail for an AI decision. This provides the structure for that. It builds trust.
Okay. So enterprise trust is key. But for developers, there's another angle that sounds really appealing, especially with AI changing so fast. Future-proofing.
Ah, yes.
The docs say it's designed so you can just swap out AI models. When a new, better one comes along, you don't have to rewrite everything.
Yes. And that is incredibly important. Think about how quickly new models are appearing, better capabilities, different strengths.
Every week, it feels like.
Pretty much. So being able to just swap in the latest, greatest model without a massive refactoring project, that keeps your application agile. It means you can actually use the latest advancements quickly.
Protects your initial investment, too?
Exactly. And add to that the version 1.0 support for C#, Python, and Java. That signals stability. No breaking changes promised. That's huge for enterprises planning long-term deployments. They need that reliability.
Definitely. Okay, reliable, future-proof. But let's get practical. How does it help automate stuff? How does it get the AI to actually do things using my existing code?
Right. This is where it gets really powerful in day-to-day use. It combines the AI's understanding the prompts with your actual APIs, your code.
How does that work?
So the AI model can effectively learn to describe your code functions. What does this function do? What information does it need? And then semantic kernel acts like the translator or maybe the orchestrator.
Yeah.
When the AI decides, I need to run that function to answer this user request, semantic kernel handles calling your actual code, passing the data, getting the result back, and feeding it to the AI.
Wow.
So the AI isn't just talking about taking an action. It's actually triggering the action through your existing systems.
Yeah.
It turns the LLM from just a chatbot into an intelligent agent that can operate your business processes.
So it's not just saying you should update the customer record. It's actually calling the function that updates the customer record.
Precisely. That's the leap.
Okay, that is powerful. So let's demystify the how. The docs talk quite a bit about plugins and functions. What role do they play?
Think of plugins as, well, toolboxes. They're named containers, basically, and inside them are the functions.
Functions being my code.
Your code, yes.
Right.
Or calls to external services, ways to get information, ways to perform actions, anything you want the AI to be able to do.
And how do you make these plugins?
You can create them directly from your native code, C#, Python, Java, or, really usefully, you can point semantic kernel at an existing OpenAPI spec.
Oh, like for a REST API?
Exactly. So if you already have APIs, you can expose them to the AI often without writing much new plugin code. You could even create functions from prompt templates themselves. It's very flexible.
That open API part sounds like a huge time saver.
It really is. Leverage what you have.
And the docs used a simple example, the Lights plugin. It showed two key concepts, RAG and task automation. Can you break that down, maybe explain RAG quickly?
Yeah, the Lights plugin is great because it's so simple but shows the core ideas. So a RAG retrieval augmented generation. For anyone listening, that basically means that AI doesn't just rely on its training data. It can go and fetch current specific information to answer a question or complete a task.
Okay.
So with the Lights plugin, the AI could use a function to get the state of the light. Is it on or off right now? That's the retrieval part, getting real-time data.
Got it. And the task automation?
That's the AI then using another function to change the state. Turn the light on, turn it off.
Right.
And the key thing to grasp is, okay, it's a light bulb here, simple. But that same pattern applies to anything. Getting the status of an order, that's retrieval. Processing an invoice payment, that's task automation. Call your payment API. Updating a database, task automation. It scales to complex business processes.
So the AI figures out the user's goal, looks at its available tools, the plugins and functions.
Exactly.
And decides which one to use. That sounds like that intelligent planning and automatic function calling thing they mentioned?
Precisely. Most modern LLMs have this built-in capability called function calling. They don't just give you text. They can say, to answer this, I need you to run the getOrderStatus function with this order ID.
Oh, okay.
Semantic kernel intercepts that request from the LLM. It understands, okay, the AI wants this specific function from that plugin.
Yeah.
It finds your code, runs it, gets the result, like the order status, and sends that result back to the LLM. Then the LLM uses that information to give the final answer to the user. Your order shipped yesterday.
So the AI actually asks for the tool it needs.
Yes. And the Quick Start Guide apparently shows this happening. You can literally watch the AI building a plan step by step to figure out how to answer a request. It's quite cool to see.
That does sound cool.
Right.
Okay, let's quickly tick off some other key components mentioned. AI service connectors.
Right. Crucial for flexibility. It's an abstraction layer. It means you can write your code once, but plug it into different AI models. Azure OpenAI, regular OpenAI, Google's models, Bedrock from Amazon, Anthropic, Hugging Face, lots of them. You're not locked
It
in.
sends vector store connectors for memory.
Yeah, these are listed as experimental still, but super important for giving the AI long-term memory or access to large document sets.
How so?
They connect to vector databases, Azure AI Search, Pinecone, Qdrant, Weaviate, others. This lets the AI recall past conversations or find relevant information in vast amounts of data, going way beyond the standard context window. It's key for more sophisticated agents.
Okay, and prompt templates. We kind of touched on prompts, but templates specifically.
Vital for controlling the AI. They let you structure the input precisely. You mix fixed instructions, context, placeholders for user input, maybe even specify which functions the AI should consider using. It's how you guide the AI's behavior and keep its responses consistent and, on task. It's where prompt engineering meets the code.
Got it. And the last one, filters.
Filters are like interception points. They let you run your own custom code before or after certain things happen.
Like what?
Like before a prompt is sent to the AI or after a function is called or before the final response goes back to the user.
Ah, so that's where you'd put logging or those responsible AI checks.
Exactly.
Yeah.
Log everything. Check if the AI is trying to do something it shouldn't. Add safety layers. Update a status indicator for the user. Very important for that enterprise-grade control and observability we talked about.
Right, it all ties together. It sounds like a really comprehensive ecosystem, and having it natively in C#, Python, and Java must make it much easier for teams to adopt whatever their main language is.
Definitely. And they've tried to make it feel natural in each language. Python developers expect things one way, C# developers with NuGet packages expect another. They've catered to that. Plus support for different ways to write prompts, the standard SK format, handlebars, Jinja 2, and ways to save them like YAML with Prompty. It just lowers the friction for developers to get started and use it with their existing tools and habits.
So let's pull back a bit, connecting the dots. What does all this mean for someone listening, someone trying to stay informed about AI development and where it's actually being applied?
Well, I think the big takeaway is that Semantic Kernel isn't just another library. It feels more like a paradigm shift, maybe,
Oh,
about how companies integrate AI.
how so?
It makes it feasible to deliver serious enterprise-level AI solutions quickly by connecting the AI to the code and systems you already have. You don't need to throw away decades of existing software development.
Right, it leverages that huge existing investment.
Precisely. Instead of building separate AI silos, you're making your existing applications AI capable. That's a really different way of thinking about it.
And that idea of sharing extensions using open API specs like they do with Microsoft 365 Copilot, that sounds like it could really help different kinds of developers work together, pro devs and maybe low-code folks.
Absolutely. It opens the door for collaboration. A core developer team could build a robust plugin for a complex internal system using C# or Java, expose it via open API, and then maybe someone using Power Platform or a similar low-code tool could easily incorporate that capability into a user-facing app or workflow, orchestrated by Semantic Kernel. It bridges those worlds.
Fosters teamwork, speeds things up. Makes sense.
Yeah, it allows different skills to contribute to the same end goal, smarter applications.
Okay, so wrapping this up. If we had to summarize Semantic Kernel, it's really acting like this powerful bridge,
Good way to put it.
connecting the super dynamic, fast-changing world of AI models
Yeah.
with the stable, maybe sometimes legacy code bases that run most businesses.
Exactly.
And it gives you a solid, enterprise-ready, and kind of future-proof way to build agents that can actually understand what's needed, plan how to do it, and then execute using your code.
That's a pretty good summary. It enables AI to act reliably and controllably within your existing world.
Which leads to maybe a final thought, something for you to ponder. Given how Semantic Kernel focuses on plugging AI into existing enterprise apps, all that existing code, does this change how we should even think about upgrading software in the future?
What do you mean?
Well, are we heading towards a time where maybe every piece of software, every API, every function we've ever written is essentially just dormant, waiting to become part of an AI agent, ready to be intelligently orchestrated by something like Semantic Kernel? Is that the future of software evolution?
That is a really interesting question, actually. Makes you think, doesn't it?
Something to chew on. That's all we have time for on this deep dive into Semantic Kernel. Thanks for joining us.
My pleasure.
And we'll catch you on the next deep dive.